whenever you talk about, mean time to recovery and mean time to sort of anything, it's always an interesting topic in terms of what's the impact, what's the outcome if those kinds of times, those kinds of numbers are too long. And I think, nobody wants downtime. Nobody wants, instant things that they have to deal with. But when you're in a financial context, a lot of times the outcomes and the downsides of this can be quite severe. And there are instances in the history of the community of the industry where hundreds of millions of dollars have been lost in just minutes due to downtime, due to bugs, due to errors. And so it's, it needs to be taken very seriously. Not that other industries don't take it seriously. Clearly, we all do. But finance is a little bit special because it's money. So everybody cares about it a whole lot. And when things go wrong, things can go very, very wrong.
Yeah, and Bob, what are your thoughts on that same topic? And I love what Anders said, that everyone needs to be concerned about this, but we're focused on money, and sometimes really big money in our industry. And Bob, I think you're on mute there.
Sorry about that.
There we go.
Yeah, so that's the you have to do that at least once obligatory on every Zoom call. There has to be a, hey, somebody's on mute. Or right. You have to tell somebody to go on mute. But yeah, no, I think that's exactly right. We're sort of Anders is right. Is the nobody cares how long it takes to resolve something if there's not some penalty involved, right? In financial services, that tends to be dollars related. But it's the impact of downtime or any kind of sort of system failure, particularly in financial services, is catastrophic, both from a financial as well as from a reputational perspective. And I think one of the things that we're struggling with is, as an industry, as we see more movements towards microservices, more movements towards these big distributed apps, is that, if you think about it, everybody says, oh, well, we've got a 99.9% reliability in our code. If I've got 10 microservices at 99.9% reliability, I'm looking at about, anywhere between 500 and 1,000 hours of downtime a year, because it's a multiplying effect. So you've got to be able to figure out in a pace where, to keep up with the market, you need to release rapidly. You have to figure out how you recover rapidly and gracefully when things go wrong, because they're going to. We are not perfect as human beings, nor software developers, or we have bugs. It happens.
I think too, the interesting thing to talk about is the whole idea of mean time to discovery, mean time to investigate, is who figures out that there's a problem, right? And if it's the customer, that's a big problem. And so the kinds of monitoring, the kinds of triggering and activities that we do around, hey, there's a problem here, is very important, because you don't want the customer to be the one discovering that there's a problem, because they can't log in, they can't transfer money, they can't complete a transaction, what have you. So being proactive in looking for problems, signaling when there may be problems, and hopefully catching something before it cascades far enough to where, okay, now we don't know where the problem started. And in the world of microservices, it's great. Loosely coupled architectures are fantastic. We're reaping huge benefits from it in the industry, no doubt. But you now have many more places to go look for problems. And whenever one problem cascades to a second, to a third, to a fourth, to 50 others, now you've got a symphony of problems. And good luck trying to figure out which player in the symphony started the piece of music, right? So it's very important that the monitoring that we do, the error checking that we do, all the things that we do before we even go into production, quite frankly, as well, are even more important, because once things start to go wrong, they can cascade pretty quickly.
Yeah, I think that's an important point, is that we think about things in terms of production and MTTI and MTTR, because that's where your cost is. But really, this process is through the cycle, right? And I know, and near to Anders' heart as well as to mine, in this age of CI and CD, and as we try to push these things forward, the more that we can catch up front, the more that we find these things before we get into production, obviously that's your best case. Your best case is it never gets to a point where a customer could experience it. And although we think about things like MTTR as a production issue, the reality is that, you know, anybody who's been in software for longer than about 6 months and gone through one release cycle knows, you know, at a certain point, you know, if you didn't fix the bug before your release date hits, somewhere on the line you ship, right? You have to ship. So the more that I can speed up that process in the development cycle, the more I free up my resources to get that stuff right the first time, that it doesn't even hit that development cycle. So it's equally important in your pre-prod and your testing and your build environments as it is in your production environments, although the impact is the greatest, obviously, if a defect hits in prod.
Yep, yep. And the cheapest place to fix a problem is on the whiteboard. Before you write the code. So always think about how far left can I shift that problem when I run into something. You know, was there a unit test I could have written? Was there an integration test I could have written? You know, the retrospective, blameless retrospective after an incident is always important to try to figure out how far upstream could we have caught that problem, and really where was the place where we should have caught that problem, so that the next time we don't run into that, and that we learn from our incidents. You know, anytime you have an incident, and I'm not the first person to say this, but it's a learning opportunity. You know, you've already paid the cost, so to speak. So now the question is, can you reap the benefit of that learning experience and put it to use going forward?
Yeah, totally agree.
Yeah, and I'm thinking about things like having development teams spend more time on new features instead of bug fixes, and really like new features. And that's something that I think we want to be focusing on, right? Having our development resources, creating those updates and new features that the end consumer are looking for.
Yeah, it's, you know, I find often, you know, you get pushback sometimes from engineers, sometimes from engineering management of, oh, I don't have time to write tests. I'm under so much pressure. I've got to get this feature completed. I don't have time to write tests. That's always a false economy. Always. You will regret not writing those tests. And you know, when that lack of testing, automated testing, and perhaps reliance on manual testing, if it's even worse, that will turn into costs downstream that are, you know, I mean, we've all seen that sort of asymptotic picture of or exponential picture of, you know, the cost of fixing a bug as time goes on, and the closer you get to production or even beyond production, it's always cheaper and faster to write tests, automated tests in particular, than it is to say, oh, I got to get the code checked in, we got to go to production, those sorts of things. You will regret it.
Yeah, it's the other is, and Nick, your point's a valid one, is that, you know, the challenge too is that, you know, a defect found in prod tends to whipsaw not just the developer who wrote who coded that module. It tends to drag your senior staff in, it pulls senior developers in. You can grind an entire engineering team to a halt whenever you have some, you know, any kind of a level of a downtime. And I think we've all experienced this somewhere. Those critical Sev1 type, you know, drop everything, they can totally derail an entire sprint. And you know, you've taken an entire engineering team out of process. The ripple effects of these throughout your engineering, you know, life cycle and your software development life cycle, you know, it's like, you know, that extra half a day you might have spent up front on, you know, improving your testing or your management, you know, just cost you a week, you know, downstream for an entire team instead of a half a day for a single person. So
yep, it's orders of magnitude difference in terms of the cost. So it's it is a false economy to say, oh, I don't have time to write tests.
Yeah. The other thing we see too is that it tends to be your more senior people that get whipsawed. You know, because, you know, it's like, okay, you know, I need to pull a lead architect in on this because I want that solution as fast as possible. So the bug might have been created by a junior dev, and, you know, or you know, even a third party somewhere, but you're whipsawing your critical resources. So it's a killer.
Yep, good point.